Hi, I have something to show you. As you can see, this is some readable code, but let me make it more readable for you. Okay, that should be fine. Maybe a bit to the right. Okay, let's decipher what's going on. um, okay. We don't need this. That was the previous occasion when I tried to record this video with my microphone muted. So let's draw what's going on. So we have public class underscore a. You can do that. It's not against the naming rules. It would be against the naming rules to just only use underscore. You can do that. But other than that, you can just do that whatever you want. Well, not whatever you want. You cannot even start with a number. But we are not here to talk about the naming rules. Jesus Christ, Greg. Come on, focus. Okay, so we have public class A. So this is our class. Don't forget to use the birds. The birds are very important. You can also call it a mustache. Or, if you are very highbrow Winnie the Pooh Chad user of Java, you can also call the first bird Pichone from Vampire Survivors. Okay, so this is Pichone, and as you know, if you are an avid Vampire Survivor player, that they always come in pairs. You can have Ebony Wings and Pichone. They have an evo which is called, I don't know, Vandalism? Something, it starts with a V, but we are also going to need the end bird, which is going to be Ebony Wings. I still want to write other stuff here and then talk about Ebony Wings. We have something like final static private string name. Okay, so that's just a static field. It's name, and it's final and it's static. These are very important, that it's final and it's static. And then we have static private string get name string s. Okay, so this method receives a string and returns a string. Fantastic. So we have get name, a simple getter actually, which makes no sense. I don't think it makes any sense for static methods. Can I make it final? Sure. I think it would work. We will see. I'm going out on a limb and say that this should be fine if I call it final. So it's going to receive a string, which is called s. And it's also final, but I don't think that matters too much. So let's see what happens with this string. What do we do with it? We just return name, okay? We just return name. That's all. And we don't do anything with string. We just go out of the scope and that's it. It's supposed to be s when we receive that it's a local variable for our method, but when the method executes, it goes out of scope, and that's it. And we did nothing to it. It's just ignored. Let's move on. Static main. Oh, static and Pichone. Static Pichone. And okay, I am not very good at drawing birds, as you can see. So the point is that this is a static initializer block. A static initializer block. So we are going to call main. The name, as far as I can remember, yes. Name equals null. We call a system out print line. This is my abbreviation for it. I don't want to write the whole thing down here for you. And we just print out a long text, but then we do a string concatenation and we call getName. And this should be fine because getName returns a string, as you might be able to recall. We add name and we do another concatenation and just add ha, because just why not? Yeah, that's it. And then we have public A, so this is the constructor, right? Constructor. And our constructor prints out hi. Good. And then we have public static void main. So we have our entry point, finally. We have our main. And let's use Pichone. Let's add Ebony Wings here, Pichone here, Ebony Wings here. Semicolons here and there. Oh, of course this is not proper code, I'm just trying to lay out what's going on. We have our usual arguments. I just love using var args because I don't know, that I don't have any reason to do that. So we are going to print out the first argument. That's an interesting one. So from the args we get the first element. And you might be raising your eyebrows now if haven't already, we are just going to create a new instance of our class, that's all, and call the constructor. Let's add ebony wings, let's add another ebony wings for the whole class. Then we are done. I think that's it. Yeah, this is our whole code. Let me save it. What's going to be printed? We have a lot of print statements here, so let's find out what's going to happen. But before I do that, I think we should understand the difference between a class object and an instance object. So whenever we want to create an instance of a class with the new keyword, we also have to load in the class before that. And when you are loading it, you can only do it once. It only happens once when you reference the class. You might be saying that, yeah, okay, we referenced the class here, which is kind of true, and we also start the instantiation of the class, and that's true. But in this case, when the JVM, and by JVM I mean the Java Virtual Machine, reads our code, it's looking for the main method, because that's its entry point. And for the main method to exist, the class has to be loaded, which has the main method. So you have to load the class first. And that's exactly what's going to happen. And when you are loading, you are paying attention to the static fields and static initializer blocks. That's very important. The static fields and the initializer blocks. So first we load the class and then we can run the main. So we have the final static name here, final static method here, the static initializer block here, another static method here, which is our main, and then the constructor. The constructor is also read and built into the class object, but we don't really do anything with it. We have everything set up. By the time we get to the static initializer block, the class is considered to be loaded and ready to go. But we still have to run everything in the static initializer block. And the first line is main. So we are going to call main, and it's going to receive a string. Why? Because we have this here. We assign null to name. Why is that important? First of all, we have to go back to our name field. When our static class variable, these are called class variables because they are static, they are not instance variables. They wouldn't be static. So our class variable is final. The thing is that final variables, no matter if they are class or instance variables, they don't receive default values. Normally they would. And since this is a string, this would receive null by default. But not in this case, because this is final. That's why it gets 0 default values. Inline, right here, you can just say, okay, without the semicolon, you say equals, I don't know, some string that you want, and be done with it. But that's not, that wasn't my choice, because I still want to demonstrate that you can either do this inline or in the static initializer block. That's also a valid place to assign value to our field, and this is exactly what this achieves. We have our name here and we assign null to it. Why would it accept null? We don't have the quotation marks. It's not a string. I could do that, but I'm just assigning null. Why is this acceptable for the compiler? Because string is a class. Classes can be null. That's it. So it's still a valid assignment. It can be null. In fact, if it wasn't final, it would receive null as a default value. So it's still okay. This is a binary operator. This is an assignment operator. It's called a binary operator because it has two sides and something happens to them. And in this case, this variable is going to store this null value. Well, not exactly, because name is only a reference. Right now, our string has this value in it, and we can reference it through this pointer, the name variable. Very nice. And as long as we have this variable in our code, we can access our string and it's not going to be garbage collected. In fact, from this point, since this is final, we can't even reassign the value because you can only do the assignment once. And when we get here, we do the assignment, and this assignment operator has a return value. And the return value is exactly the thing that you assign to the variable, which is null. So we return null. Main is expecting an array. So main is going to receive our string, which is null. The lucky thing is that I am using var args, which means that we can have only one element and it will still work. If I change this to an array, we would have a problem. We are going to print out the first element of the arguments, which is null. And that's it. First we print null. And then we create a new instance of A, which means that we have to go through all the instance fields and methods, but we don't have any. However, we have a constructor. And that's also very important. It's going to be run as the last step of the instantiation. And it's going to print out hi. Well, with a capital H, I think. So the main method is done. It has been executed. And then we go to this part. We are going to print out this very long text, blah, 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 and then call the getName method. And by the time we get to the getName method, name already has something assigned. So it's going to be fine. We can access the name. It already has a value. And we also do a string concatenation and add huh to it. So it's going to be null. Huh. It's going to be one word, one string added after our semicolon, not semi, just normal colon. And at this point, our static initializer block is ready. It's done. The JVM has gone through all the important steps to finally get to the main method, to get to our entry point and start running our code right there. So first of all, we print out the first argument. The thing is that we don't have a first argument. Okay, it really depends on us. If I write a string to the end of my command when I start the program, then it would have arguments. If I don't do that, we would get an error. Not an error, it would be an exception. Array out of bounds exception. So it's an out of, I don't know if it's a big O, out of bounds. It's just an exception. And the reason is that our array has a length of 0. And when you call the first element, it's going to make no sense because the length is 0. You have to remember that arrays are always 0 indexed in Java. So if I say I want the 0th element, that actually means I want the first element, but there is no first element. So that's why we are going to get this error message. If I actually provided an actual string argument, then everything would be fine. That's going to be printed. And then we call the constructor. The constructor is going to write out hi for us, and everything should be fine. However, if I don't provide that argument, the code is going to exit after the exception and nothing else would happen. We would get all these guys printed until we get to the exception. So let me demonstrate that. Let's come back here. Let's say Java scrap. Very nice. So we have null, hi, static init block, and random name null. Oh, where is ha? Oh, actually scratch that, I just remembered. We don't do anything with this string. Of course it returns null ha, but we don't return that. GetName actually just returns the name, which is huh. But we could change the code. We could just add ha to this and change the return statement to, where is it? Yeah, we have to go way back. GetName, string, return name, plus s. In which case it would work according to our needs. And that's how we would get null. Null. Okay. Let's save it. Okay. And now let's check the code. Java scrap. Good. And we have the null and the exception. That's very good. Now let's add something else. Let's add my argument here. It is also printed. We also have the last hi at the end of the code. Good. That's it.